This video is going to be talking about slopes of parallel and perpendicular lines for geometry. Alright, so we're going to mix it up a little bit. We're not going to have a math joke today, we're going to have a math pun. Here it is. Without geometry, life is pointless. Okay, we're going to start by comparing parallel lines to perpendicular lines. Now if you think about a graph, parallel lines might look something like this. Here's one line, and then I have another line. When you see two lines that are parallel on the graph, you will notice that those lines do not intersect. And the reason they do not intersect is because lines that are parallel have the same slope. Okay, so you might want to highlight that same slope. That's very, very important. An example might be, if I were to write the equation for this line on top, that might look like y equals 2/3 x minus 1. Then the line below would be y equals 2/3 x minus 5. They have the same rate. They are going the same vertical distance as compared to the horizontal distance. So they have the same slope, which is why they do not intersect. Now, perpendicular lines then, they do intersect. And they intersect in a specific way. Perpendicular lines intersect to form four right angles. And the slopes of perpendicular lines are going to be opposite reciprocals. Okay, that's very important, opposite reciprocals. So let's go over some examples. What opposite reciprocals look like. Alright, for instance, if I have one line that has the equation y equals -1/5 x plus 2, and another line with the equation y equals 5x plus 2, we're going to check to see if these slopes are opposite reciprocals. So the slope for the line 1 is going to be -1/5. Slope for the second line is +5. Well, the reciprocal is when you flip the fraction. So let's say I flip -1/5. That becomes -5/1. And then the opposite of -5 becomes +5. So yes, these are perpendicular slopes. Now an easy way to check this is if you multiply two slopes together, the product of two numbers that are opposite reciprocals of each other should always equal -1, which ours does. So if I multiply two slopes together, if I get the product to be -1, that indicates that those slopes are opposite reciprocals, and therefore the lines would be perpendicular. Okay, now we're going to go ahead and practice on how do we determine whether or not lines are parallel or they're perpendicular, or maybe they're neither parallel or perpendicular, and then they possibly could be the same line. Alright, to do that we really need to look at their slope. And what I want you to do is put all the lines in slope-intercept form. This is just one of the many ways we could do it. And this is where our focus is going to be. So in number 1, we have y equals 3x plus 7 and y equals negative 3x minus 4. Now, if you notice, both of those lines are already in slope-intercept form. So we need to start by finding the slopes. First slope we have is 3. Y-intercept is 7. Second slope is negative 3 and has a y-intercept of negative 4. Well, we know they're not parallel because they're not the same slope. They're not the same line because it's not the same slope and the same y-intercept. We also know that they're not perpendicular. And the reason they're not perpendicular is because although the slopes are opposites, they're not reciprocals of each other. So in this case, our conclusion is just neither. Okay, let's try number 2. Oh, I'm sorry, skip number 2, let's try number 3. We have one line, 2y minus 4x equals 16. And the second line, y minus 10 equals 2 times the quantity x minus 1. Again, go ahead and solve both of those lines for y. So for the first line, I'm going to go ahead, add 4x over, and divide everything by 2. I get y equals 8 plus 2x. So you'll notice that you have a slope of 2 and a y-intercept of 8. Now let's check the next line. Here I'm going to go ahead and start by distributing my 2. Then I want to add 10 over. Well, I also notice here I have a slope of 2 and a y-intercept of 8. Same slope, same y-intercept. These lines are not just parallel, but they're actually the same line. All right, for those 4 examples on your notes, I want you to do numbers 2 and 4. Okay, now we're going to practice writing equations of lines, which we've already done in 3.7. But now I want to do them so that the lines are perpendicular or maybe they're parallel. All right, let's start with the first one. And it says problem number 5. It's actually problem number 1 on your paper, or on here. It should say 5 on your paper though. All right, in order to make lines perpendicular, we need to start by finding the slope for this line. So the slope for this line is 3. It's a coefficient of x. But I don't want my line to be parallel to their line. I want mine to be perpendicular. So I need to use a slope that's opposite reciprocal of this slope. The opposite of positive 3 is going to be negative 3. And then the reciprocal of 3 is 1/3. So the slope I need to use is negative 1/3. Now I want my line to go through the point 2, 3. So I have a point, I have a slope. We're now going to use point-slope form. So we have y minus 3 equals negative 1/3 times the quantity x minus 2. Let's go ahead and solve this now for y. And to start, I'm going to distribute negative 1/3. So I have negative 1/3 x plus 2/3. And then let's add 3 over. So I get y equals negative 1/3 x. And you can just leave it as 3 2/3. And there's the equation of my line that is perpendicular to their line. Okay, so in problem number 6, it says parallel to the line 4x plus 3y equals 9, but we want our line to go through the point 4, -2. So I need to know what slope does this line have? Well, let's go ahead and solve it for y. So I'm going to subtract 4x. And divide everything by 3. So the slope for their line is negative 4/3 x, or negative 4/3, sorry. That's the slope that I want for my line in order for our lines to be parallel. So I now have my slope, I have a point, and again I'm going to use point slope form. Y minus a negative 2 becomes y plus 2 times negative 4/3 equals negative 4/3 times the quantity x minus 4. Let's distribute negative 4/3. We get 16/3. 16/3 is really 5 1/3. 3 goes into 16 evenly 5 times with a remainder of 1. So I'm going to rewrite it. Y plus 2 equals negative 4/3 x plus 5 1/3. Then I want to subtract 2. So y equals negative 4/3 x plus 3 1/3. And now my line goes to the point 4, negative 2, and is going to be parallel to their line. A good way to check would be to graph both of them. Okay, if you have any questions over this section, please come see me tomorrow.